This topic is called the probability of dependent events involving a standard deck of cards. So the question says here is a table showing all 52 cards in the standard deck, and as you can see in the table, you've got the 4 different suits, and then with each suit you've got the ace, 2, 3, 4, 5, 6, 7, 8, 9, and 10, and then the jack, queen, and king, the 3 face cards. And so that's 4 groups of 13, so 4 times 13 is 52. That lands you with 52 cards in the deck. The question here says a random card, or a card is drawn at random from a standard deck. The card is not put back in the deck, and a second card is drawn at random from the remaining cards in the deck. What is the probability that both of the cards are 9s? We don't round intermediate computations, and we round our final answer to 4 decimal places. So this question, rather than rewrite this table, one of the things when you click explain, I'm just going to show you part of it, shows you about what we call probability with dependent events, sometimes called conditional probability. This tells us that the probability of A and B, if A and B are dependent events. If they're independent, it's just to multiply the 2 probabilities together. But since it's dependent, it's the probability of A, and then multiplied by, the way you say that, is the probability of B given A. In other words, probability that B occurs given that A already occurred. So you have to take that into account. If there's 3 events involved that are all dependent, then it's probability of A, probability of B given A, and the probability of C given A and B. And so then that just sort of builds from there. So with this problem, let's get back up here, with this question then, we're really asking the probability, oops, just lost my mouse. I'll show you the Alex directions and explain it. My mouse just died. So the probability that both cards are 9s is like writing the probability the first one is 9 and the second one is 9. So another way of thinking about that is the probability of the first 9 and then the probability of the second 9 given that the first was a 9. So you think about those probabilities. First of all, the probability that the first one is a 9 is just 4 out of 52. You get that from looking at the table, because there are 4 9s out of the 52 cards. And then the probability that the second one is a 9, given that the first one is a 9, is only 3 out of 51. And the reason for that is that there are only 3 9s left out of the 51 remaining cards. And so that's your 2 probabilities. And so then to multiply those 2 together, 4 out of 52 times 3 out of 51, you get 0.00452. And so that 5th decimal place is a 2. So rounding to 4 decimal places, final answer is 0.0045.